Alrighty, 2-3 reading got it. I'm bringing my steps along again for the, you might want to get those out if you're struggling with those at all. Not a bad idea. What is this solution, right? Now here I've got some stuff to actually do. I've got some like terms to combine. I can't just go willy-nilly start adding 23 and then you can't divide it 5, then divide it 2. You have some like terms to combine. So before we get started, we're going to combine the 5m and the 2m into 7m. So what I've really got going on is 5 equals 7m minus 23. This looks like the ones we just did. I'm going to use my additive property, addition property of equality, add the 23 to both sides. 7m is 28. Use my multiplication property of equality, divide the 7 off on both sides, again multiplication, division, same thing. And 4 equals, or m equals 4. Again, your check. This is the important part. Go back to the original equation, plug in 4 everywhere m appears. Don't go back to this equation. Go back to the fact that you have this one here, just in case you made a mistake somewhere. So we end up with 20 minus 23 plus 8 does indeed equal 5. That's our check there. And do actually work it out. They kind of skipped that on this one here. So, alrighty. So we have some similar problems going on. We have, we'll start with A. 11m minus 8 minus 6m equals 22. Obviously I have some like terms to combine. I'm going to combine the 11m and the minus 6m. So 11m minus 6m is 5m minus 8 equals 22. Then I'm going to go ahead and add my 8 to both sides. And 5m equals 30. And divide off that 5. And m is 6. And again, the check, let me slide these guys out of the way here. The check, we go back to that original equation. And everywhere that we see m, we put in a 6. So I have 11 times 6 minus 8 minus 6 times 6 equals 22. So 66 minus 8 minus 36 equals 22. And here we can just certainly go in order. So 66 minus 8 is 58. Minus 36 equals 22. And 58 minus 36 is indeed 22. So my answer was correct. I'm going to slide that out of the way. And we'll do B real quick here. So in B, we have negative 2y plus 5 plus 5y equals 14. Combining our like terms, minus 2y plus 5y is 3y plus 5 equals 14. Now we're down to the so we need to add, subtract, then we'll multiply and divide. So let's go ahead and subtract that 5 from both sides. And 3y equals 9. And we're going to divide that 3 from both sides, so y is indeed 3. Promise that's a 9 and that's a 3. There we go. And our check for that, going back to the original equation, plugging in 3, so negative 2 times 3 plus 5. That's not going to fit there. Hang on a sec. Let me move some stuff out of the way. There we go. We'll start over with that one. So again, negative 2 times 3 plus 5 times 3 equals 14. So here we have negative 6 plus 5 plus 15 equals 14. So let's see, negative 6 plus 1 is negative 1 plus 15 equals 14, and that's true. So our answer right there is correct. Alrighty, so solving a multi-step equation. Story problems. Again, you know I love them. Martha takes her niece and nephew to a concert. She buys t-shirts and bumper stickers for them. The bumper stickers cost $1 each. Niece wants 1 t-shirt and 4 bumper stickers. Nephew wants 2 shirts, but no bumper stickers. And Martha has a total of $67. What is the cost of 1 shirt? So we're not telling you that, right? Remember I talk about let statements. Let S is the cost of 1 shirt. So we know that 1 shirt, right, so the niece wants 1 shirt and 4 stickers. And the nephew wants 2 shirts, no bumper stickers. So S plus 4 for the niece, just 2S for the nephew. Together those things are $67. So we can go ahead and drop the association here, right? And then we can look for combining like terms. So we have S plus 2S is 3S. Bring along the 4 for the ride. Now we're ready to solve. Again, our steps, we've already combined like terms. There's no distributive property, but we are to the addition property of equality, so subtract 4 from both sides. Then we're down to the division property of equality, so we're going to divide the 3 off from both sides, and the shirt are $21 each. And that's an easy one to check, right? So you find that you know you have 1, 2, 3 shirts, add on the 4 bumper stickers that are $1 each, equals 67. And again, picture your label, in this case $sign, and I really prefer the $sign goes in front because that's the way we do it here in America. The rest of the world doesn't, but we do, so that's what we're going to do here. Alrighty, so it says in this problem, Noah and Kate are shopping for new guitar strings in a music store. Noah buys 2 packs of strings, Kate buys 2 packs of strings, and a music book. The book was $16, so that one's a constant. Their total cost is $72. How much is 1 pack of strings? And as I've said in the other videos, I do expect you to start out with a let statement. So I'm going to say let S equal the cost of strings. So that's 1 pack of strings. So we know that we have 2 packs for Noah and 2 packs for Kate plus a $16 book. And they spent $72 together. So we don't have any distributive property here, but we do have some like terms to combine. So I'm going to go ahead and combine those like terms. So I'm going to get 4S, bring down the plus 16 equals 72. Now we're to our add subtract phase, so subtract off the 16, and 4S equals 56. Now we can use our division again on both sides, and we find that S is 14. The label is dollars. And again, that's an easy one to check. So you can take those 4 packs of strings, right? So 4 times the 14 and add on the 16. So again, plug that back in here, right? 2 times 14 plus 2 times 14 plus 16. And so we end up with 28 plus 28 plus 14. And obviously we are going to get to 72 in the end. So S is, or cost of 1 pack of strings is $14. So I guess that was a 16 here, wasn't it? There we go. Alrighty, so continuing here, solving an equation. This time we are going to finally have that distributive property. So that first step, again, make sure you write everything down correctly. And here we have negative 8 times the quantity 2x minus 1 equals 36. So we're going to start out by distributing that negative 8. So negative 8 times 2x is negative 16x. Negative 8 times negative 1 is a positive 8. Be careful there. Again, that negative on the front when you distribute. All that equals 36. Now it looks like the problems we've been solving. So there's no like terms to combine. We can go ahead and subtract the 8 from both sides. So negative 16x equals 28. Now we can multiply and divide, and again divide off that negative 16, and x is negative 7/4. And then your check, you plug that back in to the original equation here, and then solve according to order of operations to prove that it's true. Alrighty, now this one, it's going to look a lot like the last one. We'll start out with that distributive property after we make sure that we write it down correctly. So 18 equals 3 times 2x minus 6. Going to use our distributive property and distribute that 3 here. So 18 equals 6x minus 18. There are no like terms to combine, so I'm going to go ahead and we're going to add that 18 to both sides. And we know that, oops, that's an 8, I promise. We have 6x equals 36. Divide off that 6, and x is 6. And the question here, again, it says at work in the original equation, so we have to do the check. So 18 equals 3 times 2 times 6 minus 6. So 18 equals 3 times, let's see, 2 times 6 is 12. So 12 minus 6, 18 equals 3 times 6, and that is indeed true. So our answer is correct. Now the part B here, can you solve the equation by using the division property of equality instead of distributive property? And the answer to that is definitely yes. Let's make some room here and I'll show you that part. So remember we talked earlier about all divided bys, right? Well, this one's kind of like an all multiplied by. Now this is only going to work. Let me show you this. 18 equals 3 times 2x minus 6. It's only going to work if the entire side right here is multiplied by something. If there was anything outside of here, like if there was like a a plus 2 out here. That doesn't work, what I'm about to do, unless you subtract the 2 off first. But that's not this problem. So what we're asking is, can I divide off this 3 first? The answer is yes. So 18 divided by 3 is 6. And these are gone, so 2x minus 6. Go ahead and add the 6 to both sides. And we get 12 equals 2x. And divide off the 2, and x is indeed still 6. So it does work in this case to do that. But again, as long as there's nothing on the outside over here that you have to clean up first. Here we go, some fraction fun. I know you love fractions. As I'm recording this, I'm sitting in a class with just the Sevies because the 8th graders are all somewhere. And they all say they don't love fractions. They're wrong. I know they do. Alrighty. So the problem here is, what is this solution? Now we've got to ask ourselves some stuff before we begin. First off, do these have a common denominator? If these two did, I could go ahead and combine some like terms, but they don't, so I can't. Method 1 is to write the like terms using a common denominator and solve. I'm a big fan of that one myself. I'm sorry, I'm not a big fan of that one, rather, because I think it's more work. But notice here, common denominators are 12. 4 times 3 is 12. 3 times 3 is 9. 3 times 4 is 12. 1 times 4 is 4. So now I have common denominators, and I can go and combine like terms. So I'm going to end up with 9 twelfths minus 4 twelfths. It's 5 twelfths x equals 10. Now you use the reciprocal. Multiply both sides by 12 fifths. Again, flip over the fraction so I can clean this up. And we end up with 12 fifths times 10, which is 24. Now the method I prefer is to clean up the denominators right away. Get rid of it. And to do that, I can pick a multiplier here that wipes out both denominators. So 4 and 3 both go into 12. So I can multiply this entire side, or both sides I should say, by 12 first. Notice you see a 12 here. That's why it's mathematically sound. And you'll see that 5 pop in again as well down here. So, but again, using that 12 to multiply on the left side, so a little bit of distributive property. 12 times 3x over 4 gives us 9x, right? So if you think about it, let me make sure we've got that here. So wiping out here gives us the 3. 3 times 3 is 9. That's where that comes from. Same thing over here. This gives us 4. Right, when we wipe out the 3, so the 4 appears there. So 9x's minus 4x's is 5x. See, I told you that 5 would come back into play here. Divide out the 5, and x is still 24. So 2 methods. I'm a fan of this one in most cases, just because it's a whole lot less fraction work. Alrighty, so here I'm going to use the second method in that last problem on this first problem here. So we'll have 2b over 5, so again, make sure you copy it down correctly. 2b over 5 plus 3b over 4 equals 3. And I'm going to choose to multiply both sides by 20. Okay, by 20 over 1. So what that gives me on this side is 20 over 1 times 2b over 5 plus 20 over 1 times 3b over 4 equals 60. And we can cancel out here and get a 4, cancel out here and get a 5. So 4 times 2 is 8b plus 15b equals 60. 8b and 15b is 23b equals 60. Divide off that 23, and b we find is 60 23rds, which is the same answer given up here. Now I'm going to tell you right now, if we have horrible fractions like this, I'm going to forgive you on the check, because nobody wants to do that. Just because. I mean, check it if you want to, but obviously we're looking at the right answer here. So let's take a look at the second one. Let me get this slid out of the way. Down here you might be tempted to multiply both sides by 6, and you could do that. It's going to involve a little more fraction work, but I'm looking at getting rid of the 9 over here too. So I want to multiply both sides by 18. You're going to get the same answer no matter what, but I'll multiply both sides by 18. Oops, 18 over 1, not 18 over 18. There we go. So on the right side, that's going to leave me with 2 equals. Then I'm going to have 18 over 1 times 5/6 minus 18 over 1 times m over 3 So 2 equals, and on the left side we're going to get 15 because we're going to have a 3 times 5 here. So I'm going to have 15 equals, and then over here that was a 3, so we're going to have minus 6m. There we go. Subtract off our 15, and we get negative 13 equals negative 6m. Be careful not to lose the negative there. Divide off our negative 6, and m we find equals 13/6. Again, as long as the fraction is reduced, I'm good with it being improper, because that works, unless it's a quantity. Like, you wouldn't want to say 13/6 loaves of bread. That'd be weird. That'd be like 2 1/6 loaves of bread then instead. But so there you go on that one. Again, looking at the idea of cleaning up the whole thing rather than really, it kind of knocks out the need to deal with fractions most of the problem. So here, throwing in some decimal fun. Here we have 3.5 minus 0.02. And again, obviously I know it's 3 5/10, right? It gets cumbersome to say all those things like 2/100 x equals 1.24 or 1 2400. So, great thing about decimals though, you can wipe those out real quick and easy. You look at how far the decimals go in, right? 2 spaces. Well, 2 zeros is 100. So we can actually force some distributive property in here, and we can make it 350 minus 2x equals 124. So again, notice distributing to get rid of the decimals makes the problem a lot nicer. Subtract off the 350, divide off the negative 2, and x is 113. Those are a lot nicer for the simple facts. It's just quicker and easier. Okay, so solution here, we have 0.5x equals, nope, sorry, not equals, subtract, minus, that's what I'm trying to spit out, minus 2.325 equals 3.95. And here we can start out by multiplying both sides by, notice how many decimal places, so we're going to go 1,000. There we go. So, I don't know what to say. Alrighty, so we're going to distribute the 1,000 here, so we're going to get 500x minus 2,325 equals 3,950. We're going to add that 2,325 over to here to both sides. And we get 500x equals 6,275. Go ahead and divide off the 500. And x then is 12.55. And again, noticing, wiping out those zeros, one of the nice things with decimals, makes them pretty slick. So, there you go.